In order to meet the acute global need for bioinformatics training, Welcome Connecting Science provide advanced courses in bioinformatics at our UK campus and with local partner organisations in Africa, Asia and Latin America. These courses are always in very high demand. There is limited capacity for expanding our training. We therefore developed online training using a MOOC model to reach a wider global audience, including people who may not be able to travel for in-person training, even if travel costs are covered. MOOCs are massive open online courses. They're hosted on the internet and open to anyone with a web browser. Basic access is free of cost, and in our case, our funders sponsored free upgrades for all learners. MOOCs are designed to be highly scalable, so there is no requirement to limit participant numbers. We partnered with the FutureLearn platform, who specialise in social learning. MOOCs on FutureLearn use a semi-synchronous model. Learning is divided into 1-week blocks, meaning that learners can access the course in their own time, but can interact with their cohort of learners via discussion forums. This avoids the problems of live training, such as time zones, internet problems, clashes with work or personal commitments, but provides opportunities to learn from and share experience with others, according to L'Oréal's conversational learning model. Our courses are designed to promote engagement with social learning by using prompts for discussion, reflection, and interaction throughout. A potential downside of MOOCs is that they are less well suited to hands-on training. Being able to actually apply analytic and computational tools is critical for effective learning in bioinformatics, as well as being generally educationally desirable. Therefore, we used innovative approaches to give opportunities for learners to experience key bioinformatics software, using freely downloadable genome browsers and annotation tools for visualization, analysis, and comparison of sequences. We provided step-by-step instructions for downloading and installing these tools in the form of screencast videos or annotated screenshots. We also designed hands-on exercises, allowing learners to practice with the tools they were learning about and discuss their outputs with other learners and with educators. We included formative and summative assessments, allowing learners to check their understanding and eventually achieve a certificate of completion. We collaborated with subject experts to develop our courses. As part of a pilot, we created a set of 3 bacterial genomics courses, 1 introducing the subject, and then 2 training learners in use of specific freely available analytic tools, Artemis and ACT, the Artemis comparison tool. We provided sample datasets, allowing learners to gain hands-on experience of these tools. We then added to our portfolio an introductory course on Linux, Bash scripting, and R. This was designed to introduce basic computational techniques to an audience of life scientists, because use of command line tools can be a major obstacle to access our own and others' bioinformatics training. Since starting our online courses program 3 years ago, we've reached over 60,000 people, and analytics show participation from more than 180 countries. We've successfully attracted learners from low and middle income countries, with high numbers attending from India, Egypt, Nigeria, Pakistan, Bangladesh, Sudan, and Mexico, among others. There was a huge surge of interest in all online learning in 2020, especially in the second quarter of the year, when the majority of the world's population were in some form of lockdown. The new course introducing biologists to Linux, Bash scripting, and R was launched in February this year, 2021, and a single run attracted as many as 12,000 learners. This reflects the very widespread need for accessible resources on this topic. Our experience shows that the social and conversational learning model is highly scalable. Educator teams, with guidance from Welcome Connecting Science, put significant effort into development of the course material, adapting it to this conversational learning MOOC format, making learning as interactive as possible within the constraints of the format. After this front-loaded design effort, educators provided light touch facilitation, requiring only a couple of hours a week during the live runs of the courses. We found learners engaging with their peers, asking questions, providing help, sharing their experiences, and indicating that they had acquired and planned to apply new skills. This led to high learner satisfaction, even on courses with over 10,000 participants learning simultaneously. With these bioinformatics courses, experts sometimes had to step in to help with technical issues, such as downloading data, running software on a whole range of different systems. Most learners were able to carry out at least some exercises, even without the intensive one-to-one IT support that would be provided in a face-to-face course. After the success of this program so far, we intend to expand our offering of bioinformatics courses to cover a wider range of topics and continue to address unmet need worldwide.